All right. Hello and welcome to Learning with Mr. Favor. I don't know what we're going to call it, but this is our middle school tutorial for math. It's actually going to be a tutorial kind of for all the grades in math, but this will give parents as well as a reminder for students an example of how we solve story problems here at Change the World Schools. So we use a curriculum that is based off of Singapore math, which is actually based off of Japanese math, which is proven time and time again to be one of the most efficient ways of teaching math. And one of the key things that they do is they talk about how to solve story problems. So for this tutorial, I'm going to go through two story problems coming from our 5th grade books on how we would solve these story problems. And you'll see very quickly that these story problems are going to be solved in a way that you can actually see it's setting the children up to prepare them for algebra when they get there. So even from 1st grade, we use this bar system so that they can conceptualize what it is they're doing in algebra, which is in essence taking a symbol like X or Y and turning it into an empty box that needs to be filled. So let's use this first story problem. If you are following along with us at home with your paper, it is the practice 1D page 25 in the book. So here we go. Question 1 says, John is 15 kilograms heavier than Peter. Their total weight is 127 kilograms. Find John's weight. So we're going to go ahead and start this story problem off by drawing ourselves a bar. And I get to cheat a little bit by using some digital perfect bars, but anyway, this is going to be our first bar for John. And since John is the heavier person, then we're going to make another bar for Peter. And we're going to make this one smaller. We can make it about that much smaller. Now we need to give it a label. I'm going to give J for John. And I am going to, I need to move so I can use my tablet more efficiently. I'm going to make a P for Peter. There we go. Now, we don't have any information of how much John weighs, so that is actually a question mark. We also don't know how much Peter weighs, so that's also a question mark. The only thing we do know for certain is that Peter weighs 15 kilos less than John, which means this difference here between this bar and this bar is a difference of 15 kilograms. We also know that both of them together combined is 127 kilograms. So this is the information we're provided. Now, in a story problem like this is a 5th grade problem, again, just to remind you, but in a problem like this, one thing that we would encourage the students to do is that we need to find a way to separate John and Peter. And the only way we can separate them is by using a division tool. But we can't divide until they're both equal, at least temporarily. So what we're going to do is we're going to do actually one of two things, because a student yesterday proved that you could do it 2 different ways. So the first way is we could add 15 to this total amount. That means we're adding Peter's weight. We're imaginarily adding 15 kilograms to Peter so that he weighs the same. The other option that this particular student did was subtract 15 kilo from John's weight temporarily. Again, we'll add it back later. So there's 2 ways you could do this. For this particular example, we're going to, why don't we subtract John's weight? So in this case, for our first equation, we're going to do 127 minus 15. That is going to be our first equation. So what is 127 minus 15? think I heard you say it through the camera. It is going to be 112. 112. So now we know that the imaginary weight of John, if he was as light as Peter, would be 112 kilograms. So then our second step is to divide that in half so that we can figure out how much Peter weighs. Oh, whoops. We're not going to do 127. We're going to do 112 divided by 2. And 112 divided by 2 is, I hope you said it, 56. 56. Okay, so now we know that Peter weighs 56 kilos. We also know that John doesn't actually weigh 56 kilos. He weighs 56 plus 15 kilos. So we have one more problem to do because we're trying to figure out John's weight, not Peter's. So we're going to do 56 plus 15. And that would be 71 kilos. So now we figured out John's weight, which is 71 kilos. So we've done actually 2 parts of this story problem. The requirements, the requirements that I ask of students when they are doing these story problems is that they make a deal. The first is the drawing or creating the bar. So this bar system is the first thing. The second is the equations. I guess I should write equations. And that is those over there. The third is answer, of course. Very important to know your answer, especially when you get into these heavier problems where, for example, we found out that Peter weighed 56 kilos, but that wasn't the answer. I mean, we did discover that answer, but it wasn't the answer to the question because the question was saying find John's weight. So very important for them to remember that, to find that answer. And then the last part is labeling. This is very labeling. This is very important because if you are not sure what your label is, then this kind of loses the whole point of why we're doing story problems. I mean, going back to our practical education, story problems are helping simulate practical situations. So understanding why I did my calculations, but then understanding also what that answer amounts to. So not 71 Johns, not 71 pounds, but 71 kilos. So then my answer might look something like this. Copying the question, I could say John's weight is 71 kilograms. Oops, my pen does not like making dots. And that will be my final answer. So that is how we do an addition or subtraction kind of story problem bar. Let's do another example. This one will involve multiplying. So let's go to number 2 on the same page. There are 3 times as many boys as girls. There are 24 more boys than girls. How many children are there altogether? So in this case, what we're going to do is we're going to make a bar again. But this time, let's undo that. There we go. This time, we're going to make a bar that represents. Let's do a bar that represents the girls first because the boys are the ones that are multiplied out. So this down here could be our bar for the girls. If I can do a neater G. There we go. And then for the boys, we are looking at something 3 times as big. again, when you're drawing this on your paper with pencil, it doesn't have to be perfect. I get to cheat a little bit because I'm using a computer, but even if they're not perfect, you're making the assumption when you're doing a multiplying problem that your bars sections are going to be all the same amount. So don't waste too much time trying to make them perfect. Okay, so let's then, we've kind of followed this. There are 3 times as many boys as girls. So what else do we know? It says something about 24. If there's 24 more boys than girls, so again, it's using this over here. It's saying that this difference here is 24. And it is asking how many children are there altogether. So we're actually trying to figure out this question right here. And right now, that's all we know. We don't know how many girls there are. We don't know how many boys there are. So if you want to, you can put a question mark in every single box. I like to put one in just one because that is going to be the same as all those. I also might, in these multi-step problems, I might circle the question that is the real question, the one that it's asking right here. How many children are there altogether? So if I get sort of caught up in all the details of this stuff and then forget what my real question was, this will remind me that that's the ultimate question. Okay, so then we're going to take a look. What can we do? Well, we got this 24 here, and this 24 represents 2 of the blocks. So you know what? My first my first equation might be something like 24. Whoops, you still want to do that, don't you? 24 divided by 2. Because if I divide 24 by 2, it will figure out how much is in one of these blocks, which will answer my first question. So 24 divided by 2 is 12. Okay, so I know now that each of these blocks are 12, so I can erase that. Whoops, I can erase that little question mark. Erase, yeah, thank you. I can erase that question mark, and I know now that there are 12 girls in this story problem, and I know that there are going to be 12 boys, which means that I need to do my second equation, which is going to be 12 times 3. And 12 times 3 is, you guessed it, I hope, 36. Okay, so now we know how many boys there are, we know how many girls there are. Now, because I circled my question, I know now that that's not my question to answer, how many boys are there or how many girls there are. The question is to answer how many boys and girls are there. So I got one more equation to write, which is 36 plus 12. 36 plus 12 is 48. And that's my final answer. So as I'm making a deal, I've done my drawing and I've done my equation. Now it's just time for that answer and label. And I'm going to say, copying the question, how many children are there altogether? There are 48 children altogether. Okay, and that's how I would answer that problem. So, 2 things that I sort of have this imaginary questions coming out. Maybe the first one's coming from more the students, which is how detailed do I have to be in my equations? After all, if you're in 5th grade, 36 plus 12 is a pretty simple problem that you can probably do in your head. The answer is be as detailed as possible. It doesn't seem to make sense. If you can do stuff in your head, then why should I write it down? And the answer is kind of a 2-answer reason. One is for the teacher. The teacher's just checking to make sure that you are able to process it, or the teacher's trying to decide, because some of these story problems you can do 2 ways or 3 ways or 4 ways, and so the teacher's trying to figure out which method you used. The second reason, though, is that it's showing that you are able to understand and conceptualize what it is you're supposed to do. Sometimes people are so good at math, and I was one of those kids once upon a time, a long time ago, where I just knew the answer, but I didn't know why. And that works great for a few grades. But once you get older, once you get into algebra and geometry and trigonometry, knowing just because you know is not a good reason, and it won't keep you going, and you're going to run into some problems. So that is why we do the equations. For parents, I mean, the second thing that's coming up, but I want you to sort of see this now, and you can sort of tell that what we're doing here is in fact algebra, because these boxes, for both of them, are going to be something like X. And so as we transition, as they get older and they start transitioning to pre-algebra, then they're going to understand better when we start saying something like this, where we're trying to figure this stuff out, and we're saying, hey, there's 3 times as many boys and girls, so if girls are X and boys are 3X, and there's 24, how would we do this? 3X plus, so then we do, maybe I should have thought through this one a little bit, but anyway, but the whole point of this is going to be that when we're doing these problems, these boxes are representing empty variables that eventually in pre-algebra we start assigning them. And so this is why it has been proven over and over again, Japanese math is a very efficient math. Just to differentiate, it's not more strenuous or harder, it's more efficient in the methods that they use to teach it. So you can see with this method here, it's very clear-cut and straightforward, and it will help students to better understand how to complete math in a conceptual way. I hope this has helped. Stay tuned for more, and everyone have a great day. Thank you.